Okay, this is the first of several semester final reviews, number 61. I already have some notes that we did in class, but I'm going to go ahead and complete everything, and you can check your answers and then also play these back as you need, to learn how to do them on your own. Remember, the goal is not just to have the answers on your paper, but to know how to do this by yourself. So if I gave you this review as the actual final and it was completely blank, and you had no help, you should be able to complete the whole thing. So print out several copies and make sure you can do these all by yourself. Just do them over and over and again until you got it all by yourself. Okay, so the first one's already started. So remember, when we're factoring, that just means your answer is two things being, or three things being multiplied by one another. Okay, so as you can see, my answer is going to be of this form when you're factoring. When you're solving, that's when your answer is actually x equals. So we want to multiply 1 times 45, right? That goes on top, a times c, and then b is on the bottom, negative 14. So the two numbers that multiply to 45 and add to negative 14 are, see, you can try different combinations, but I think it's going to be 9 and 5. Those multiply to 45, but to add to negative 14, they both have to be negative, because they still multiply to positive 45, and now they add here to negative 14. So my factors are x minus 9 and x minus 5. Okay. Number 2, we already did it in class, so remember, take out the greatest common factor. If you see something that goes into all the terms, so like 6 goes into 6 and 24, you can take that out. If there's an x in every term, you can take that out. So this is factoring a GCF out. And it just makes everything smaller. And again, later on we can solve this if we need to. But for this, it's the final answer because we're just factoring. So starting on number 3, that's when we actually have to solve. Okay, so remember, when you're solving by factoring, that means you're finding the x-intercepts. So keep that in mind. What this gives us are the x-intercepts if we're graphing. That's the whole purpose of solving, is to find the x-intercepts. Okay. So this is a lot like number 2. There's a single number that goes into both of these, which is 5, so you can take that out. Right? And this doesn't have an x, so unlike number 2, we can't take out an x. Even though this has it, this does not. So you just divide basically 5 by everything, so we'll be left with 4x squared, and then 125 divided by 5 is 25. Okay. Now, you're not done just because we took out a GCF, because this can be factored even further. And I know that because it has two characteristics. Number 1, they are perfect square numbers. Okay. Oopsie. Perfect squares. Okay. Meaning they're 9, 16, 25, 36. These are not random numbers. These are good numbers that will help you factor a lot faster if you recognize them. Okay. And the second thing, it has to be subtraction. Okay. And another way of saying that is a difference. So we call that a difference of squares. When there's two perfect squares being subtracted, then we can say what multiplies to 4x squared. That'd be 2x and 2x. And what multiplies to negative 25, well, that would be positive 5, negative 5. Okay. And again, we're solving, so this is equal to 0. Okay. So what we do from here, for factoring would be done. There would be 3 different factors. But for solving, we have to set each one of these equal to 0, and that'll give us x-intercepts. Now you'll notice I did not use the 5 here. You can if you want, you'll get the same answer, but really what you do is you just divide both sides by 5, right? That cancels out, and this still just equals 0. So it doesn't matter that there's a 5 here, because when you divide it, it ends up equaling 0 on the right. So we can subtract 5 on both sides here. Right? So we have negative 5 over 2, or negative 2.5. And similarly, over here, we'll have a positive. Right, we'll have positive 2.5. And you can leave it as a fraction, or you can do a decimal here. Either way, it doesn't matter. But just notice that for solving, you must have x equals as your answer. Factoring just means you have the factor, so it's kind of like the halfway point. So like right here, that's the factoring, and then the solving is where you have it equal to 0. Okay. Same idea here, kind of point out that these are perfect squares again. See, 9, 16, not random numbers. So if you see that, you can always try this. Now this isn't the same thing because there's 3 terms, even though it is a difference. It's not the exact same thing, but we can still go about from the beginning in the same way. So to get the 9x squared, it's still 3x times 3x. To get the 16, it's still 4 and 4, 4 times 4. But instead of having one positive, one negative, right, we're going to have 2 of them negative, right? And that way we'll get negative 12 by multiplying the outside and negative 12 multiplying on the inside. So the 2 negative 12x's give us the 24 negative. Okay. Whereas over here, right, we got negative 10 and positive 10, which is 0. That's why there's nothing in the middle here, because it's 0. But over here, we have negative 24. That's why both of them need to be negative, is to get negative 12 and negative 12. Okay, and this is solving, so still equal to 0. And like we did before, we'll have 3x minus 4 is 0, and 3x minus 4 is 0. So it's really the same thing. Don't really need to do both of these because you'll get the same answer. So I'm just going to do one of them, knowing that the other one is the same answer. So 4 over 3 is my answer. And if you did put 4 over 3, 4 over 3, it's okay, but really not necessary to put it twice. Okay, so that's the factoring and solving part. Let's go ahead and do some graphing with it. Again, the solving part actually gave us the x-intercepts. So if we were to graph this, these would be important numbers to use. And that's where this starts first and actually tells you to make sure you solve by factoring first. So the first part of number 5 is really just to do what we did in number 3 and 4. So we're going to have x squared plus 5x minus 6x plus 5, right? So what 2 numbers multiply to negative 6 and, multiply to 5 and add to negative 6, and you'll get negative 1 and negative 5. So we got x minus 1 and x minus 5. And again, you got to solve it equals 0. So I get 2 answers, x equals 1 and x equals 5. Those are my x-intercepts. Okay? So x equals, right this way, 1 and 5. So I know on the graph they'll cross here and at 2, 3, 4, 5, right? The x-axis, that's where they go. Axis of symmetry is always right down the middle. Okay, so the middle of 1 and 5 is 3, because 2 to the left is 1, 2 to the right is 5. The vertex will be the axis of symmetry, comma, well, whatever you get when you plug in 3. So if we go back up here and plug in 3, we'll have 3 minus 1 and 3 minus 5, which is 2 times negative 2, negative 4. So my axis, my vertex is at 3, comma, 1, 2, 3, negative 4. Okay. The y-intercept, okay, that's right up here. Okay, that's 5, C. So the y-intercept is 5, or 0, 5, either way. Okay, so that means 1, 2, 3, 4, 5. There's a point. Remember, you get another on the other side as well, because of symmetry. I don't need to plug it in, I just know. If I plugged in 6, I would get 5 as well. And that's enough to make a complete parabola. Okay, there we go. And is the vertex a min or a max? Remember, this is the vertex right here. Okay, right there. And it's at the bottom, right? It's lower. So it's going to be a minimum, just because it's at the bottom. And explain your answer. How do you know that? The parabola opens up. So you can say something like that. The parabola, opens up. Or you can say A is positive. So because A is positive, it opens up, so you have to have them in. And A is that would be equal to positive 1 here, because x squared is the same as 1x squared. Okay, so that's graphing a parabola. Let's go over to the back. Do number 6. Okay, kind of started this in class together, so it actually tells you, if you go through it and read it, it says set both equations equal to each other, so that's a good place to start. Okay, but while you're doing this, might be a little confusing, so I graphed this on Desmos just so you can see what you're actually trying to do. So your friend, you're going in a curved path, right? That's the red one here, and your friend's going in a straight line, so you can see where it crosses twice. So it's asking you, well, what are those intersections? Basically, where do these run into each other? Okay, where are they equal to each other? That's why we set them equal to each other. So if we solve this, the first thing we got to do is get it equal to 0. Everything we do, we want to get it equal to 0. So since it's positive x, I'm going to subtract x. Since it's positive 3, subtract 3. Just do that to both sides. Okay. So we have x squared minus 5x, and this is 0. So this looks very similar to number 2 and 3. Okay, so go back up here. So it has a GCF of a variable. Both terms have a variable in it, right? So the first thing you want to do is take out a GCF. So take out the x from each of these. So if you take out an x from x squared, you'll have an x. If you remove the x from negative 5x, you just have the negative 5. And there you have it. We got to solve it now. So x equals 0. X minus 5 is 0. So x equals 5. So my x-intercepts are 0 and 5. Okay. So what we just found graphically is that I know one intersection is going to be right here at x equals 0. Okay. So at x equals 0, if I go up, that's where it intersects. And if I go to 5 right here, that's where the other intersection is. It doesn't tell us exactly how high to go, but at least we know on the x-axis where they happen. So we want to plug in 0 and plug in 5, and you can find out where these exact points are. Okay, so if we plug in 0 into either one, it doesn't matter because that's where they equal. So we just plug it into, let's say, here, right? So we have 0 plus 3. This will be y equals, by the way. So y will equal 3 when you plug in 0. So one intersection should be 0, 3. And if I plug in 5, right, so y equals 5 plus 3. So we get y equals 8. So my other point will be 5, 8. And I could have plugged it into this other one and gotten the same numbers, 3 and 8, but this is a little bit easier. Okay, and if we go back to our graph, remember, 0, 3, and 5, 8, we can see where they intersect. Right here at 0, 3, and right here at 5, 8. So that's what this question was asking, where would they run into each other? One's going a curved path, one's going a straight line. Where would you run into one another? Should I get that? There it goes, right there. Okay. All right. So yeah, it says find the x, y coordinates. So I have the two, and it does say points, right? That's a hint that you should have more than one answer, right? So make sure you do have both. Okay. Now let's go to radicals. I mentioned this in class. So to simplify a radical, it's very similar to reducing a fraction, but instead of just dividing top and bottom by a number like a fraction, you have to divide whatever's on the inside by a perfect square. So again, you're looking to divide it by 4, 9, 16, 25, 36. You're looking to divide by one of these numbers, not just any number. So when you're doing fractions, it doesn't matter what number you use, but with radicals, it does. You have to divide by one of these. Okay? And if possible, you always want to go with the largest one. So if you have, like, let's say number 8, 72, you say, 9 goes into 72, that's good. but 36 does as well, and since 36 is bigger, we want to use that. So to start off number 8 here, I'd break up 72 into two numbers, one of them being from this list that will keep on going, 49, 64, and so on. And 72 is 36 times 2. Now, how do you actually know that? It just takes some trial and error to learn that and to remember 72 is 36 times 2. There's no easy way other than just using a calculator and just pressing 72 divided by 49. See if it's a whole number. 72 divided by 36, it goes in even, so you know to stop. And you notice how I started with a large number and worked your way down. So this part, square root of 36, I can take the square root of. It's 6, because 6 times 6 is 36. Everything else stays the same, so I'm just going to rewrite -5. And I can't take the square root of 2, and I can't reduce that more, so I'm just going to bring that down as well. These two are just plain old rational numbers, so -5 times 6 is -30. And once again, bring down the root 2 because we can't do anything to simplify it. Okay, so that's your final answer for number 8. Okay. Square root of 25 over 36, again, you should not see these numbers as random coincidence. Like they're perfect squares. That means you can easily take the square root of them. Another way of looking at this is you can just take the square root of the top and take the square root of the bottom. All right, so square root of the top is 5, square root of the bottom is 6. And that's it. Nothing more to it. All right, number 10. We got some rational, meaning non-radical part, and we have some irrational, the radical part. So let's multiply them together respectively. So 2 times 4 is 8. And 6 times 6 is square root of 36, right? 6 times 6 is 36, but since they have radicals, answer's in a radical. But you again can take the square root of 36. It's 6. All right, so we have 8 times 6, which equals 48. Final answer. Okay, same thing on number 11. Multiply the rationals together. -4 times 3 is just -12. And the irrationals, the radicals, we have 10 times 2, which is 20. So again, you're always checking to see if you can reduce it. So does one of these numbers go into 20 evenly? And after a little bit of searching, you'll see that, yeah, 4 goes into 20. So that means you can reduce this to root 4 times root 5, because 4 times 5 is 20, and just bring down the -12. Okay. And square root of 4 is 2. And just bring down everything else. Right? Root 5, can't reduce root 5, it stays. And then lastly, multiply the two rational numbers together, so we got -24 root 5, and that's your final answer. All right, so that's the first review. Now, I go kind of fast because this is the speed you want to be able to do this at when you're done. So the question is always, how do I know if I'm done studying? If you can do what I just did at the same speed and even explain it the way I am, or adding a little bit more or less, then you're ready. If you have to stop at any point and say, wait, it's too fast, where'd that come from? That means you need to keep redoing this over and over again. So watch the video, print out multiple copies off of School Loop and in class or at home, and just keep repeating it until you can basically do this whole review in 20 minutes by yourself with no help, and then also get 100% correct. That way you know you're absolutely ready for the final. Okay? All right, we'll go and do part 2 right now.